Today we're going to talk about coterminal angles. Coterminal means share a terminal side. Recall, when you are graphing an angle, you have initial side, that's always on the positive x-axis, and then it rotates up or down, and it stops at the terminal side. Let's start with 60 degrees. Let's remember, when you sketch, if it's positive, you go up. That right there is about 60 degrees. Now it says find one positive and one negative coterminal. So you start always at your initial side, and you have to go to the terminal side. Well, if I do that, I have the exact same angle. So I need to make one complete revolution and stop there again. So I did my initial 60, and then I did one complete revolution, which, remember, in degrees is 360 degrees. So I took 60, I added 360, and my new angle is 420 degrees. Okay, now I'm going to start at my initial side again and go to the terminal side, but I need a negative, so that means I'm going to go down. And I'm going to stop right there. If you look at this closely, your 60-degree angle and your negative coterminal make a complete revolution. How this will work then is if I take my 60 and this time subtract 360 from it, my negative coterminal angle is negative 300, because I went down to the terminal side, and then the rest of it was 60 degrees. So 360 makes a complete circle. Let's do this one. Negative 330. Start on the initial side, go around, approximately stop right there. If I want to find a positive coterminal, start on your initial side, go up until you hit the terminal side, and make sure it's not the same exact angle. It's not. So if I use my rules that I said, if you're trying to find a positive, add 360. So I started with negative 330, I add 360, and my positive coterminal is 30 degrees. Well, let's make sure that makes sense. 30 degrees and 330 should add up to a revolution, which it does. Negative coterminal, go down, hit the terminal side, check to make sure it's not the exact same. This time it is, so that means I need to do another complete revolution. Remember, a revolution in degrees is 360 degrees. I'm looking for the negative coterminal, so that means I subtract 360 this time. So we have negative 690. I like to use the visual, but just doing the math there works as well. Now we are moving on to radians. 4 pi over 3. 4 pi over 3 is, if you remember, the number on the bottom breaks your top and bottom into thirds. So I have 1/3, I have 2/3, I have 3/3. If I start here and I go around, I stop right there. That is positive 4/3. If I use the rule up here that I'm trying to find a positive coterminal, I add 360 degrees. But remember, 360 degrees is the same as 2 pi. So this time I would take 4 pi over 3, and I'm trying to find a positive, so I would add 2 pi. In order to add them together, I need to have a common denominator. So I would change this to 6 and this to 3. So that would be 10 pi over 3. Now let's test it. I need a positive coterminal that is coterminal to 4 pi over 3. Start here, go around, and I stop at my terminal side. That is 4 pi over 3. I need to do another full circle. 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3. So that was perfect. Now I'm going to take 4 pi over 3 and find the negative coterminal. So start and go to the terminal side. That is 1 pi over 3, 2 pi over 3, negative. But if I want to use the rule, I'm going to subtract 2 pi, get a common denominator, and my answer is negative 2 pi over 3. So you can count or you can use the rule. I am going to just use the rule for this one. Negative 7 pi over 4. If I want to find a positive coterminal, I just add 2 pi. But remember, in order to combine these, you need a common denominator. So this becomes 8, and this becomes 4. My positive coterminal, negative 7 plus 8, is 1 pi over 4. Now let's find a negative coterminal. Negative 7 pi over 4. This time I subtract 2 pi. To combine them, I need a common denominator. Since we have a 4 here, this becomes 8 over 4. Negative 7 and negative 8 is negative 15 pi over 4. There you go. Ask questions if you have them. Thank you.